Okay, so this is 2b 5 part f. So in this question you had the function f of x equals 7 log x for x being any real number and x being greater than 0, and you have to find the range of the function and then whether it's a one-to-one or a many-to-one function. So the best way to get the range of the function is to sketch the graph of y equals 7 log x. So you could choose some values of x. So if you chose x equals 1, for example, and you work out that, you're going to have 7 log 1, which will be 0. You could choose x equals 2 and work out 7 log of 2. So if you do that on your calculator, that will give you 2.11 to 2 decimal places. You could do x equals 5 and work out 7 log of 5, and if you do that you get a value of 4.89. You could choose some values less than 1, obviously greater than 0 because you're restricted to x is greater than 0. So if we chose x equals 0.5, for example, and we worked out 7 log of 0.5, that will give us minus 2.11. So the graph ends up looking like, and you would have looked at this when you did logarithms with Mrs. Thompson, so we know when x is equal to 1, f of x is 0, so it has an intercept there, and it looks something like this if you draw out 7 log x. So you plot the graph and then you look at the values that f of x can take. Well, this graph carries on indefinitely down here. If you worked out f of something like 0.1 or f of 0.0001, it will end up being a very big negative value. So f of x can take any value, any real number for that one. And then whether it's a many-to-one or a one-to-one function, well, for every one value of x that you take, you only ever produce one output. So this is a one-to-one function. And then the other question you asked about, which was question 7 part C. So you had a function for that one, s of x equals, and it was split into 2. So it was x squared minus 6 when x is less than 0, and it was the graph 10 minus x when x is greater than or equal to 0. So you had to sketch the graph in the first part, and I'm going to sketch it now, so that's going to help me to do part C. So on my set of axes, plotting graph of x against s of x. So when x is less than 0, I've got a quadratic. The quadratic y equals x squared minus 6. So it's going to be symmetrical about the y-axis with an intercept down there at minus 6. Obviously it can't actually get to that point down there because we're only looking at x being less than 0, not equal to 0. Then I need to draw the graph y equals 10 minus x when x is greater than or equal to 0. So that's going to be a straight line with a negative gradient of minus 1 and a y-intercept of plus 10. So it's going to look something like this if we drew it out. So it's going to go through there at 10. And again, if we let y be equal to 0 here, that means that it's going to cross the x-axis at 10 as well. So your graph will look something like that. And then we're asked to find in part C where s of x is equal to x. So we now need to draw the graph y equals x onto our graph that we've just drawn and find where the graph that we've just drawn is equal to the graph y equals x. So y equals x is going to end up going through the origin with a positive gradient of plus 1. So we need to find where they're equal to each other. So we've got 2 points where they're equal, one here and one here. So if we go about solving those, so this one here, if we call that A, that's where our quadratic meets the line y equals x. So if we're solving quadratic, we remember we want it equal to 0. So if we subtract x from both sides, so we've got a quadratic that's equal to 0. And then you can see if you can factorise that. And that gives you two solutions. Either x is minus 2 or x equals 3. But we can clearly see from the graph, x can't be 3. So it must be this solution that we're looking at for that one. And then this point, we also need to find point B. And that's where our straight line, which had equation 10 minus x, met the line y equals x. So that means 2x equals 10 and x equals 5 if we solve that one.